Hey guys, you are on mensuration topic and we continue doing explanation about different 3D solids, how to calculate surface area. In the previous video, that was foundation level for basics, how to calculate the total surface area for cubes, cuboids. Here that was interesting problem with cuboid, so make sure you watch that. And there I also explain how to figure out the total surface area for the triangular prisms. All right, so here we go next, and this is the last problem in this part. We are going to find the surface area of the rectangular base pyramid. Okay, so grab your notes and let's get started. So what we're going to do, we're going to determine the total surface area of that pyramid. So pyramid is simply represented by the base and four lateral sides around. So in this case, as you can see, they mark the base is simply a rectangle. So that's why we can draw basically a rectangle. So I just simply split into parts and say, okay, we have first of all a rectangle. So the size for a rectangle right now is 12 by 8. And this is the bottom part. So how to calculate the area of the rectangle? We just need to multiply the sides. Okay, 96 centimeters squared. So well done. And this is the bottom part or the base of the pyramid. So we've done that. All right, what about triangles? In order to calculate the area of triangles, first of all, let's count. So triangle, let's say A. So I think better use that marker. So that's A, B, and C. So, and let's say A, B, C, D, and point F there. All right, so we mark triangles, vertices of triangles, and now we know that the area of triangles is simply height by the base over 2. So that's why for each triangle, first of all, we need to find height, okay? And the total triangular area, or let's say total area, is going to be equal to area of rectangle that we recently calculated. And on top of that, we need to add area of this frontal triangle ACB, but the same triangle behind, right? Because they have the same basis. And as you can see, all sides are equal. So that means all triangles are isosceles. But first of all, we just calculating the area of each one. So ACB, triangle ACB. And on top of that, we need to add that laterals triangles also double, because this triangle has the couple there from that side. So that's why we just simply need to add two areas of triangle BCD. So we need to add area of a triangle BCD times 2. Okay, so well done. The first part we know is area of rectangle, we calculate there, and we need to find area of each triangle. How to work it out? So what I recommend to do, you need to have the height, right? So you need to have the height. How you can do that? Let's consider that you have one triangle. So for example, let's draw the triangle, and that's B is going to be triangle ACB. It's right there. So this triangle is an isosceles one, so we can put sides A. So it's 12, so I'm just going to, okay, there were sides, yeah. Sorry. Okay, what we're gonna do. So just simply mark A C and B, AC and B. And what we're gonna do, we need to put the height. So I mark height as that one. And you remember that in an isosceles triangle, because two sides are equal, and each side, lateral side by 10, while the base is 12, this perpendicular, this height, h, actually will split the bottom part into equal sides. So because CK, let's say, is going to be a bisector, so an isosceles triangle. So on top of that, this is the height, so the angle is right angle here. So we in this manner we arrange the half of the triangle, and this triangle is so right angle. How to find the height from there? So that's the height sitting here. How to find the height? We can use Pythagoras. Before we also used Pythagoras. We'll also use that, so let's complete simply h is going to be equal side BC squared. Square root of BC squared is 10 squared minus KB. But hold on, what about AB? The total, the size of 12. The total, the size of 12. But because it's bisector, so KB is going to be just 6. So that's why we subtract 6 squared from there. Okay, so we've got 100 minus 36 in square root. That means we'll get 64 square root, which is 8. So we've got the height is 8 centimeters. And that's for triangle ACB. So that's why we know height, and now we are able to calculate area of the triangle ACB. So the area is 1/2 height times the base AB, which is in that case 12 by 8 and over 2. So 8 times 12 and over 2, which gives us 48 in total. 48 centimeters squared. Alright, so we've got that. And now what we're gonna do, we're just gonna use the same approach in triangle ABCD. So I'm not gonna show you like detailed calculations, but however I put the height right there, and just simply it will split the bottom part by 2 parts. So h for that triangle ACBD, so just consider triangle BCD and just find height from there. So height for that triangle I mark as h star, so it's right there. So this is h star. It's going to be 100 minus half of 8 is 4. So it's square root of 10 squared minus, using Pythagoras, the same approach as 4 squared, and h star is going to be, let's use calculator. So in this case, 100 minus 16. And what I've got, 9.70. So 9.70 centimeters. But we need to calculate area, so area automatically is going to be, just need some space. So using h star, we can calculate the area for triangle CBD, C, B, and D. It's going to be 1/2. So h star times the base BD. So if we calculate that, we'll get some number here. So let's go there. Now BD. So BD is 1/2 h star, so 1/2 9.17 times BD. In our case, BD is 8. And if we calculate that, we'll get 4 times 9.70. And what I've got 36.68 centimeters. squared. Okay, that what stays for the area of triangle CBD. So we have all the measures for each particular area right now. And what I'm gonna do, I just squeeze a little bit. And what we're gonna do right now, we just want to use those values. So area for triangle ACB is 4.8. Oh, sorry, it's 48 centimeters, yeah. And area for triangle CBD, or BCD as we mark here, is 36.68. So what we can do, we just simply plug those values into the final formula. So we are there, we use that formula, and we find the total area right now. So total area is the area of rectangle first. It's 96 centimeters. So 96 centimeters. On top of that, we need to add double area of ACB, which is 2 times 48. 2 times 48. And finally, we add double area of BCD, which is, in this case, it's 36.68 right now. So 2 times 36.68 in total. And finally, the total area, we almost there, is going to be, let's just calculate, 96 plus 2 times 48, and on top of that, 2 times 36.68. Final result, 265 and 36 centimeters squared. So 265.36 centimeters squared. That's the total area for triangular base pyramid. So actually, as you saw here, we used Pythagoras, and that's probably the most complicated part. However, for higher maths, it's pretty easy. And we decompose the area by pairs. So some faces had pairs, and unique base is single one. So we add area of rectangle. If the area is just triangular prism, like tetrahedron, for example, we just need to add area of the bottom part, which is triangle. So the principle stays the same. Now you can expand this knowledge into more complicated class of problems. So try to do by your own, but I'll try to prepare them in the revision. All right. So hope you like that. If you're new here, please subscribe, share this video to anyone who is interested in math, and see you later.